Okay, let's just jump right in. If you're starting out with Android development right now, you're stepping into this world well, it's super powerful, but let's be honest, it can feel like a total maze. You've got libraries, patterns, best practices coming at you from all directions. It's a lot. So, what we're going to do here is draw you a map to navigate all of it. I mean, does this sound familiar, this quote? It's from a real developer, someone who's just trying to figure things out. And I bet it's a feeling a lot of us have been through. You've got this great idea, you want to build something cool, but then you hit that first big wall. Where does this bit of code even go? Trust me, you are definitely not alone in feeling that way. All right, so our whole goal here is to take that feeling of chaos and just turn it into clarity. We're going to break the entire modern Android stack down into 5 main pillars. You can think of this as your blueprint, your guide to building apps that are solid, easy to manage, and, actually modern. So here are our 5 pillars. We're going to start with the basics, the language and the look. Then we'll get into the blueprint for how to structure your app. After that, we've got the engine room for handling data, the plumbing to connect everything, and finally, the safety net to make sure it all works. All right, pillar number 1, the language and the look. Let's get down to the absolute fundamentals. What language are we actually writing in, and how do we get stuff to show up on the screen? Today, the answer is pretty clear. It's Kotlin and Jetpack Compose. So Kotlin is really our foundation. And yeah, it plays nice with all the old Java code out there, but its real magic is in its modern features. We're talking about things like null safety, which means way fewer of those dreaded null pointer exception crashes. Plus, it's just concise. You write less boilerplate code to get the same job done. Ever since Google made it the official language back in 2019, the whole Android world has really shifted to be Kotlin first. And make no mistake, this isn't just a trend, it's official. Google's own docs, their training materials, it's all built around Kotlin now. So everything else we're about to talk about, it all sits on top of the power and the features that Kotlin gives us. It's way more than just a different way to write code. It's really the bedrock of how we build apps today. Now, for the other half of this duo, Jetpack Compose. See, for years and years, we built Android UIs in these separate XML files, totally disconnected from our app's logic. Jetpack Compose completely flips that on its head. It's a real game changer. You build your entire UI right there in your Kotlin code just by writing functions. You basically just describe what your UI should look like for any given piece of data, and Compose takes care of all the hard work of drawing it. It's so much faster, way more intuitive, and it means your whole app lives in one language. It's awesome. Okay, so we've got our language and our UI toolkit picked out. That brings us to pillar number 2, the blueprint. We know the tools we're using, but now what? We need a plan for how to organize all our code so it doesn't become a total mess. And that, my friends, is where architecture comes in. And I know what you might be thinking, because this question comes up constantly. For my small little side project, isn't all this architecture stuff just overkill? Can't I just throw all my code into 1 or 2 files and be done with it? And look, the short answer is, yeah, you could, but you really, really shouldn't. Let me tell you why. Here's the deal. A good architecture forces you to separate your code into logical layers. Your UI stuff lives over here, your business logic, the brains of the operation, lives over there, and your data sources, like your database or network calls, live somewhere else entirely. This separation makes it so much easier to find things, to change one part of the app without accidentally breaking another, and this is the big one, it makes your code testable. And just remember, this is a guideline, not a strict set of rules you can never break. It's there to help you, not to lock you in. So the blueprint you're going to see everywhere is called MVVM, which stands for Model, View, View Model. Here's the simple version. Your view, that's your Compose screen, is basically dumb. Its only job is to show data and tell the view model when the user taps something. The model is your data layer. And the view model? That's the bridge between them. It gets the data, does all the thinking, prepares it perfectly for the UI, and handles all the user's actions. So, to answer that question from the start, should I put it in the view model? A great rule of thumb is, if it's logic or state, yeah, it almost certainly belongs in the view model. And if you ever wonder why the view model is so critical, just take a look at the Android activity lifecycle. It looks complicated, right? That's because your app screens are constantly being created, paused, resumed, and even completely destroyed by the operating system. A view model is special because it's designed to survive those events. So when you rotate your phone and the screen gets destroyed and recreated, your view model is still there, holding on to your data. A solid architecture is what helps you manage this built-in complexity. All right, on to pillar number 3, the engine room. This is all about handling data and concurrency. So here's the problem. How do you do something that takes a long time, like, say, fetching a bunch of data from the internet, without your whole app just freezing up and becoming unresponsive? The answer is concurrency. And luckily for us, Kotlin gives us this incredible tool called coroutines. Back in the day, managing background threads was a nightmare. It was really complicated and easy to get wrong. Coroutines make it feel like you're just writing simple, normal code, one line after another. The magic word here is suspend. A coroutine can start a task, then suspend itself, basically pause, without blocking the main UI thread. This lets your app stay buttery smooth. Then, when the task is finished, it just resumes right where it left off. No more frozen screens, no more of those awful application not responding dialogues. So what does that actually look like? Well, in your view model, you'd launch a coroutine. From there, you call a special suspend function to do the heavy lifting, like a network request. Inside that function, you can use something called with context to instantly switch over to a background thread. That keeps your main thread totally free so the UI never stutters. Then, once the data comes back, the coroutine automatically brings that result right back to the main thread for you, ready to be displayed on the screen. It's super elegant. Okay, so you've got the data. How do you actually get it to the UI? You need something to hold that data and let the UI observe it for changes. Now, if you look at older projects, you're going to see something called live data used everywhere. But the modern approach, the one that works perfectly with coroutines, is Stateflow. It's a part of a bigger thing called Kotlin Flow, which is designed for handling streams of data. Think live updates from a server or a database. The bottom line, for any new app you're building today, Stateflow is definitely the way to go. Moving right along to pillar number 4, the plumbing. Think about it. We have all these separate pieces now. View models, data repositories, network services. How do they find each other and talk to each other? The last thing you want is for your view model to be manually creating a network service. That just leads to a tangled, unmanageable mess of code. We need some proper plumbing to connect everything cleanly. And that plumbing has a name, dependency injection, or DI for short. It's a simple idea with a huge impact. Instead of a class saying, okay, I need an analytics service, so I'm going to create one myself, it just says, hey, I need an analytics service. Can someone please give me one? It seems like a small shift, but it changes everything. Your code becomes decoupled. The pieces aren't tightly stuck together anymore. This makes it super easy to swap out components, and you're probably noticing a theme here. It makes your code so much easier to test. Now, I know dependency injection can sound kinda intimidating and complicated, but here's the great news. Google built a library called Hilt that makes it ridiculously simple on Android. Really, you only need to know a few key annotations, these little tags you put on your code. You add one to your application class, another to your activities, and then whenever you need something, you just slap an @inject on it. That's pretty much it. Hilt figures out how to build and provide everything for you. It does all the heavy lifting. And that brings us to our 5th and final pillar, the safety net. We've done all this work. We've built this beautiful, well-structured app. But how do we know it actually works? How do we prevent it from crashing and make sure we don't break things in the future? Well, we write tests. A really good testing strategy is all about using the right tool for the right job. You've got your super fast unit tests. These run right on your computer, and they're perfect for checking small, isolated pieces of logic, like a single function in your view model. Then you have things like UI tests. These are a bit slower because they have to run on an actual device or an emulator, but they're absolutely essential. They check that your screens look right and that buttons actually do something when you tap them. To build a really solid, reliable app, you need a healthy mix of both. So there you have it. That's our safety net. And that's the last of our 5 pillars. We've covered the whole journey, from the language you write in and the UI you build, all the way to making sure it's all rock solid with testing. So let's step back and put it all together. Let's look at our complete map. And here it is. This right here, this is your map to modern Android development. When you sit down to start a new project, this is the stack you should reach for. UI, Kotlin and Jetpack Compose. Structure, NVVM. Concurrency, coroutines and stateflow. Dependencies, health. And quality, unit and UI tests. This isn't just, one possible option among many. This has become the standard, the well-paved road that the whole community is building on. Think back to the beginning. It might have felt like a confusing maze, right? But once you understand these 5 core pillars, the whole picture changes. That maze transforms into a well-organized city, a metropolis of opportunity. Now you have a clear plan and powerful, standard tools that let you focus on what really matters, building amazing things for your users. The chaos and confusion, they're replaced by a clear path forward.